Hello friends, today we will solve some problem on derivatives on the set of complex numbers here. Problem is, if f of z is equal to z cube, then prove that f dash of z is equal to 3z square by using the definition. Okay. Now, proof of that here it is. As you know that derivative definition, f dash of z is equal to limit delta z tends to 0, f of z plus delta z minus f of z divided by delta z if it exists. As I have explained you in the last class, the same definition I have wrote here. Now, what is f of z given? Z cube. Now, just substitute there as in the formula here. This is nothing but z plus delta z is what? A small increment given to the value of z there. It becomes delta z cube minus f of z is z cube divided by delta z. If it exists, that means you have to find the limit of this here, which is equal to limit delta z tends to 0. You expand this by using your elementary formula a plus b whole cube, that is a cube plus b cube then plus 3 a square b, this is a term and this is b term considering, then plus it becomes here 3 ab square delta z whole square minus z cube divided by what? Delta z. Yes, this is here. Now, simplifying that term here, see, observe that this and this get cancels here. Now, it becomes here, 1 second. Now, that is equal to here limit delta z tends to 0 here delta z cube, you observe that here delta z cube, delta z cube, delta z cube is common. That common I am taking outside delta z, right here 1 is common there delta z, remaining is what here delta z square plus here again 3z square. See, delta z is you have taken outside, so 3z square plus what becomes here 3z, here 1 delta z is outside. So, remaining is delta z divided by what? It is divided by delta z, that is equal to, next step, this is equal to limit delta z tends to 0. See, this delta z and this get cancels here, it becomes what? Delta z whole square plus 3z square plus 3z delta z. Now, you apply the limit z delta z tends to 0. Therefore, this term tending to 0 and this term is equal to 0. Therefore, what remains here? This is 0, this is 0, the term which is 3z square. So, you have got derivative of or d by dz of z cube is equal to how much? 3z square. As you did in your real numbers, that is, if f of x is equal to x cube, then what is the derivative? You are writing in this form f dash of x or d by dx, one and the same. It is nothing but what? 3x square. In the same way, you have got in the complex number also z cube derivative is 3z square. Again, in the same manner, you can solve the other problems also. This is purely by using your definition. Now, let me take another example here. One here, second problem here. F of z is equal to here mod z square, right? Mod z square. You have to find. See, f of z is equal to mod z square. Now, find the limit, find f dash of z if it exists. Why this question I have given this here? Right, f dash of z if it exists, you have to observe the limit value of the given function there as per the definition of f dash of z, we don't know that at this extent as we have did in other problem, earlier problem. Now, let me discuss how what is the derivative of mod z square. As we know that, before going to that, here I am going to simplifying mod z square. What is mod z square? As I have defined in the earlier section, in the introduction part of complex number, that is mod z square is nothing but what? Z bar. You know that here. So, I am using this definition here. So, therefore, f dash of z is equal to what? Limit delta z tends to 0, f of z plus delta z minus f of z divided by delta z. If it exists, always this condition is there. That is equal to limit delta z tends to 0, right, which is z plus what is this is here, apply here z plus delta z square minus mod z square divided by delta z. This condition is always there, I am not writing again and again. So, now that is equal to, now you have to observe this here by using this definition here, okay. I will write for your convenient, I am writing here inside. Now observe here, this is z plus delta z whole square is equal to how much? By using this definition, z plus delta z into z plus delta z bar, that is conjugate. That is nothing but z plus delta z. According to that property of that conjugate, I have explained in the last class, which is nothing but, which we can write in this form here, which is nothing but on simplification z bar, again plus z bar into delta z plus by multiplying this here z into zeta z bar plus delta z into delta z bar. Therefore, ultimately z plus mod z whole square becomes this here, right. And also we know that mod z square is equal to z bar. Go back and substitute here, find the limit. Okay. Next step, continuing that, here it is. This is equal to f dash of z limit delta z tends to 0. Here it becomes what? See the first term z bar plus z bar delta z plus z into delta z bar plus delta z into delta z bar, this is the first term here, minus z bar divided by what? It is delta z as per the definition. So, now you have to find limit of this function here. Now, simplification, usual idea, this and this get cancels there. Now, remaining limit z tends to 0, that here it becomes here z bar. See, while writing itself you simplify delta z by delta z, it is equal to how much? Cancels there 1 plus here it becomes z into delta z bar divided by delta z plus again delta z by delta z get cancels there. What remains here? Delta z bar. Therefore, ultimately you finding out derivative is equivalent to finding out the limit of this here now. Okay. So, you have to discuss this, the value of delta z in two different form. As you know that a complex number, it contains real part and imaginary part. So, therefore, you have to observe the limit of this in two style here. We will continue this in the next session. Thank you.